Okay, proving an identity. Section 12(2). Basically, we need to show two sides of an equation are always equivalent. And yes, this is a proof. It's not a two-column proof like geometry, but it still has to be sort of complete. The thing that would be handy that you should have would be your basic identities. I have them here on a reference sheet, which I would propose you get used to trying to think about doing this, like when you take the Regents. You have this on a chapter 12 sheet that I gave you. So these first ones are the reciprocal identities. These guys are the quotient identities. And these guys over here are the Pythagorean identities. And so we're going to hopefully use these guys to prove some other things to be true. So here we go. Before I get going, I'm going to give you a couple tips. Okay. Let me just give you sort of a sample of the ones that we're going to do. So we're going to prove sec theta sine theta equals tan theta. We're going to prove sine theta times cosec theta minus sine theta equals cos squared theta. And without saying them, I'll just sort of cruise through these other ones. Okay, now they may look a little messy, but hopefully they'll make some sense to you in a minute. So when we approach one of these things, what we should do, what's going to help us, is to work with the crazier side first. So I'll be saying that again. The basic identities are going to be our ticket, oftentimes, to just getting the job done. And that's what I just showed you. There's going to be other times where we're served something that has parentheses in it, and good old distributing sometimes will make the thing become easier so we can deal with it. When we have fractions, common denominators end up working so we can add fractions. Yes, we got to deal with fractions here. It's algebra trig. That's what we do. And also there's going to be situations where we have complex fractions. We might have a fraction within a fraction that we might need to reduce to lowest term. So these are just kind of tips to keep in the back of your mind. Okay, so we'll start in a place that hopefully isn't going to be too painful. So we need to prove that sec theta sine theta is equal to tan theta. So I always like to put a little question mark here because at this point I have not proven this. So using the tip, we use basic identities. If you remember, sec theta is the same as 1 over cos theta. So I'm going to write that. Times sine theta. And you want to be sort of methodical about this. You need to show the steps. You got to like work yourself through this. It's a proof. You got to have a reason why you're ultimately going to cut to the chase that these guys are equal. So hopefully then you see that when I take 1 over cos theta times sine theta, which is really over 1, I can join forces, and this really is the same as sine theta over cos theta. And now, using one of our quotient identities, we can be done with this thing and say, well, yeah, that's true. Tan theta is equal to tan theta. So we have completed the job. So the others are similar, but just maybe just getting a little more difficult. Okay, prove sine theta times cosec theta minus sine theta equals cos squared theta. Once again, I'm going to put a question mark. This is an example where using a little distribution might make this thing more user-friendly. So I'm going to go ahead and do that. Sine theta cosec theta minus sine theta times sine theta is sine theta squared. We write it as sine squared theta. And I'm just going to write a question. So remember, I know we haven't been dealing with the trig stuff like this lately. We've been drawing graphs more, so you might need to readjust to this notation. Okay. Keeping my basic identities in the back of my mind, that's why it's nice to have that sheet kind of handy. You recall that cosec theta is the same as 1 over sine theta. And so this might start making this a little simpler so I can get to where I'm headed here. So sine theta over 1 times 1 over sine theta is just 1. Now, it is possible that you may look at this and say, wait a minute, 1 minus sine squared theta is cos squared theta. And I'll take you back to this other sheet as a place to think about that. Now, normally we think of this Pythagorean identity as sine squared theta plus cos squared theta equals 1. But in reality, if I subtract sine squared theta off this side, I have to do the same over here. And you can see how 1 minus sine squared theta is equal to cos squared theta. So I could potentially, at this point, declare that cos squared theta, 1 minus sine squared theta equals cos squared theta. But just to maybe be a little bit more complete, I am going to go ahead and write in that cos squared theta plus sine squared theta is actually the same as the number 1 minus sine squared theta. Leave my question marks along here still. And then I can very clearly show that I have a positive sine squared theta minus sine squared theta, which goes to 0, and then punchline, cos squared theta is equal to cos squared theta. Okay, 2 down, 2 to go. Next one. 1 minus sine theta equals cos squared theta over 1 plus sine theta. Start with a question mark. Hopefully you'll agree that this side is definitely looking a little yuckier. So I'll just drag this side along for the ride right now. Now, the more you practice these, the better you get, so it might take you a little while to start figuring out what to do. But seeing that sign down there makes me want to do something to get that numerator to have a sign in it. And we really just kind of met this solution out of this mess right here, because cos squared theta is equal to 1 minus sine squared theta. So I can do that replacement right now. So I'm going to go ahead and in place of cos squared theta, I'm going to write 1 minus sine squared theta. Now this is where you cannot allow yourself to do any kooky making up math. Like these guys are, I want to call them married couples if that's something that helps you, and they cannot be split up. Like I can't divide out the ones or do something with the signs. What I can do is remember that this guy here is really no different than one of these guys, like 1 minus x squared. And if that's not comfortable, maybe thinking of it like this is more comfortable, x squared minus 1, where we learned of these things called differences, a difference of 2 perfect squares. And if you recall, we could factor those guys pretty easily. So even though this is maybe yucky looking trig, we can do the same thing. Keep my question mark here. And so that 1 minus sine squared theta is the same as 1 minus sine theta times 1 plus sine theta, all over 1 plus sine theta. And once again, the more you do these, the more you start seeing the way out of the mess, because you're realizing, especially seeing this down here, ooh, I might be able to divide that out. And sure enough, I can. So 1 plus sine theta divide out to be 1. And all that's left is the same thing on both sides of the equal sign. So I get the job done. Okay, one more. Cotan squared theta over cosec theta plus 1 equal cosec theta. Prove this to be true. And the left side clearly is the messier of the two. So this would be an example where, in the end, we just need this whole left messy side to equal one thing on the right. So there's some benefit to thinking about joining these guys up into one fraction. So cosec theta plus 1 is a good common denominator. And this is where, if you struggle with fractions, you really might need to do a little review, because it's going to cause you some trouble if you forget how to get common denominators and things like that. So cotan squared theta comes to the party as it is, because it's already sitting on cosec theta plus 1. This plus 1, which is really over 1, the 1 in the denominator, in order to become cosec theta plus 1, is getting multiplied by cosec theta plus 1. So that means the top also needs to be multiplied by cosec theta plus 1. Now, things really don't look much cleaner on the left, but we're starting to get there. Now this is where having your little sheet handy might help, because cotan squared theta plus 1 might look a little familiar. And if you look here on the sheet, 1 plus cotan squared theta is equal to cosec squared theta. So I'm going to come back here and I'm going to make that substitution. So in place of cotan squared theta plus 1, I'm going to put in cosec squared theta. And I still have this other cosec theta up on the top. All over cosec theta plus 1. Now, maybe you're starting to see the light here. And in some ways this is similar to the last problem, because what I'm trying to do is get a way to divide this guy out. And believe it or not, I have found that way, and I'll just sort of try to jog your memory by this thing here, even though it might seem like yucky trig, is really no different than something like this. And something like this, we can factor an x out of. So with that sort of in the side of your mind, we can actually factor a cosec theta out of this thing. So cosec theta times cosec theta, that gets me my cosec squared theta back, plus 1. That gets me my cosec theta all over cosec theta plus 1. Does that equal cosec theta? Not yet, but almost. So now I can divide these guys out, and what is left is cosec theta is equal to cosec theta. So, anyway, I know sometimes these might feel a little bit difficult, but if you can just hang in there and try to stay positive, I swear you can do them.